Okay, here's some review material for class 2. Part 1, let's start with trigonometry. All right, trigonometry begins with the circle, and sometimes we start with the unit circle. Let's start with a circle of radius r, and I'm drawing this radial vector, so it goes from the origin out to some point on the circle, and it's up at an angle alpha. The angle we use is kind of arbitrary, but the way I always saw it in math class was to start at the x-axis and go counterclockwise. So that's how I've done it here. Trigonometry is all about right triangles. So let's take this radial vector and drop down a horizontal, drop down to the horizontal with this right angle. Now that gives us a right triangle. What do we remember about trigonometry and right triangles? Well, hopefully we remember, and if not, that's why we're here for review, that the opposite divided by the hypotenuse is the sine of the angle. And in a more useful form for us is to say the opposite side is the hypotenuse times the sine of the angle. And similarly, we have the same thing for the adjacent side, only now we use the cosine. So this is the form that's really useful. If we have a vector r, and it has a length of r, and it's up at an angle alpha, then the opposite side, the y component of this vector is r sine alpha, and the x component is r cosine alpha. Okay, another useful trigonometric function is the tangent. Tangent is opposite divided by adjacent. And if we just look here, the opposite was r sine alpha, the adjacent was r cosine alpha. The r's cancel, and we just get sine over cosine. So that's sometimes useful. It's also rather useful for going the other way. What if we had this vector? So we have the x value, and we have the y value, and we want to know what is the alpha. And in 380, we covered this, so this should definitely be a review. We have in programming, in C++, we have this function atan2, which will give us the arctangent. So that means if I have the opposite and I have the adjacent, plug those in to atan2 and it'll tell you the angle, right? So let's try an example. An example might come in this form. What is the angle between these 2 points? So pause the video here, see if you can work that out on some scratch paper and see what you got. All right, hopefully you've worked this out on your own. If you had any trouble with it, or if you just want to check your work, let me go through it here. Okay, here are 2 points, and I've created an axis here. The first thing I like to do very often is just draw the thing. So let's take these 2 points and drop them on the axis. I have 2 minus 3, 0, and I have minus 1, 9, 0. I just put those as points as the axis, and I draw a line. It doesn't have to be all that precise. Just a sanity check, like give yourself an idea of what we're talking about. So what are we talking about? We got this line, and we want to know the angle. The angle from the bottom one to the top one. From here to here. What does that even mean? What is the angle? Well, what we said before was the angle was counterclockwise from the x-axis, right? So let's do that again here. And we said from this angle, or from this point up to this point. So let's take a horizontal through here and go counterclockwise up to there and tell me what is that angle. Okay, let's make a right triangle. So I'm just going to drop straight down to make a right triangle. Now this side is pretty easy to see is the opposite. And what is that? That is simply 9 minus 3, or 12. Cool. How about the adjacent? Here's the adjacent. Now, the adjacent, it's sort of pointing away from the angle in this case, right? And that's going to indicate a negative value. When we had it in the first diagram, it was over here. That was where we put our positive values. So if it goes this way, it must be a negative value. So watch out for that. So once again, the adjacent should just be this x value minus this x value. And so that's -1 minus 2, or -3. All right, so now we have our opposite and our adjacent. We plug them into atan 2, and the answer should come out as about 104 degrees.